Okay. All right. Do me a favor, please take out your practice test. I'm going to be printing off a different version, which you can work on tonight. I'll also give you an answer key, which you don't have to do the whole thing, just spot check the things that you get stuck on. And we can do some of it in class too. It's printing off as we speak, so it should be done in about 5 minutes. Out of the 19.
How much ink do you think this will go through in a year?
Excellent question.
What about paper?
Several rainforests, I'm sure.
How much money is that? I mean, like, just these past 2 weeks, I've literally gone through like a whole ink cartridge.
I hear ya.
Cartridge.
All right. So practice test out. Any of those you would like to see dissected?
Can we just continue where we were at? We're at
Yes.
number 7.
Did we do number 7 yet? Or?
Yeah, we did.
We did that? Okay. Number 8?
Yeah.
You can do that?
No, just like go on from there.
William large. All right. Number 8 is this.
Close. I know.
X squared minus 7x minus 8. Gentlemen in the back. Tuning in. At 10. Notes out. And practice test out. And then x squared minus 2x minus 35. And they want to solve for this being less than 0. So you tell me. I dump a problem in your lap like this. How do you start? Yeah.
First, can you do the unfoil or foil?
You're right first time.
Oh, unfoil.
Unfoil. It's a factor. Does the top unfoil?
Yeah.
Go for it.
I don't know.
Okay. Anybody? What number is add up to negative 7 and multiplied by negative 8?
8 and negative
8 and negative 1. Which one is which? 8 and negative 1 would be positive 7.
1.
Yeah. Negative, well, actually negative, that's the same thing.
Oh. Negative.
I like the two numbers. Negative 8, positive 1. Is it negative 1 and 8?
Oh, in order.
No, I mean, if the negative belongs to the 1, you get a different answer. You get a positive 7 here. Can somebody unfoil the bottom for me? Oh, math people.
X minus 7x plus 5.
Yeah, should be x minus 7, x plus 5. They add up to negative 2, they multiply to be negative 35. With a little trial and error, you can do that. Again, if you get stuck, I would split the last one up. You get 1 times negative 35, 5 times negative 7, 7 times negative 5, blah, 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 blah. And then this one works. So it's in less than 0. What did that give you? What can you now find? Yeah.
That's just
Right. Where are the roots?
at 8 and 1.
Okay.
Negative 1.
At x equals 8 and x equals negative 1. How about vertical asymptotes?
7 negative 5.
Yeah. X equals 7, x equals negative 5. Question, are there any holes?
No.
No. How do you know?
Because none are the same on top of that.
Right. The only time a hole happens is if there are two identical factors on top and bottom, like x plus 5, x plus 5. So, we've got roots, we've got vertical asymptotes. What do you do with them to solve a problem like this? Yeah. Right. Let's do plus minus notation. Go for it. What kind of, how many breakpoints do we have total?
4.
4. Let's mark them. What's the one that's furthest to the left?
Negative 5.
Yeah, negative 5 is a what?
Vertical asymptote.
Vertical asymptote. Little dotted line. Then,
Negative 1.
negative 1. Gentlemen, tune in. Let's not chit chat. And then that's a what?
For root.
A root. Solid dot. No, take over.
So there's a vertical asymptote at 7,
Yep.
and then there's a root at 8.
Correct. And you don't have to space them out, artistically, but carve them into regions. It's region A, B, C, D, E. You don't even have to label them A, B, C, D, E. It's Yeah, why? That's a good one. You can do 0. X equals 0. If that's true, then y equals what? You notice I would use the factored version. You don't have to. You can use the original one. All I care about is if it's positive or negative. Plug in a 0 for x. What would that make this parentheses? Negative. Keep going. Positive. Negative. What does that mean? Yeah, that makes a positive region because negative over negative cancels. C is positive. Can anybody fill in the rest of them for me? Yeah.
D negative, D positive, D negative, A positive.
How do you get that so fast?
This just changes with every root or vertical asymptote because it's the same.
Right. All of them are single roots and single vertical asymptotes. The signs will always switch when jumping over them. What if you had a double root? Would that switch? Stay the same. How about double vertical asymptote? Stay the same. How about quadruple vertical asymptote? Quadruple is 4.
Oh, quadruple. Oh no, it's
Stay the same. How about octuple? That's 8. Stay the same. Nonuple, which is 9. Switches. Exactly. Any odd multiplicity will switch for roots and vertical asymptotes. So, finish the problem for me, Sophie. What are they asking for? Yeah, they want regions that are negative. Do they want the endpoints? No, they're not even asking for the endpoints. There's no equal, so they don't want the endpoints, even if they're safe. Does that make sense? If this had been less than or equal to, they'd be asking for the endpoints. Now keep in mind, the fact that they ask for it doesn't mean you have to give it to them. If it's safe, give it to them. If it would kill them, don't. That's such a good life lesson when you're raising kids. They say, well, gee, should I give this nuclear bomb to my son or daughter? No. Why? Because it'll kill them and probably 500,000 other people. Just don't. So, would you give them roots as endpoints? If they want them? Yeah. Would you give them vertical asymptotes? No. Even you with all of your sins, would you give your son or daughter a vertical asymptote when he asks for a root? Yeah, that's in scripture. Yeah, moving on. Yeah, the snakes are trying. So what's your final solution, Sophie? X belongs to what?
-5 and -1.
-5 and -1. Good, that's the first negative. Do I want to include the ends? So what kind of brackets? Round. Good. And then what's the other part?
X belongs to whatever 7 and 8.
Done. That's the end of the problem. Does that make sense? The actual problem on the test is probably not going to be any bigger than that. There might be a hole in it, there might not. So be alert there. Does a hole switch the sign?
Not usually.
Not usually. What's the only rare exception?
If it lies on x-axis.
If the hole is on the x-axis, and that only happens when what? Yeah.
Oh, I just had a question about
Go ahead.
something
Question.
else. Are they all round brackets? I thought the -1 and the 8 would be square brackets.
It would, but this thing isn't even interested in them.
Oh.
If it's less than or equal to, they're asking for them. This thing says, I don't want endpoints whether they're safe or not. Does that make sense? Okay. So, and then when does that happen? When does it, yeah.
When there's a war between
A war between
between
what and what?
a root
Root?
and a vertical asymptote. No, a hole.
A hole. Between a root and a hole, correct. And who wins?
The hole.
The hole. So that would be on the x-axis, correct. By the way, is there ever such a thing between a war between a vertical asymptote and a root? No, because that actually turns into a regular hole. If you have something on top and something on the bottom, that would have been a war between the two, but that turns into a genuine hole. So that's not actually a war. That's just a category we already have. So the only thing you can have a war with is a hole. So you can have a hole versus a root, or a hole versus a vertical asymptote. Make sense? Everybody get a number 8? Think you can do that on a test? Like tomorrow? All right. of the test.
Oh, yeah, Mr. Kaplan.
Yes.
I was just gonna ask, are all the problems on the front the same ones that'll be on the test? I mean,
More or less.
like, a couple of them.
I'm probably gonna
ones
change
that
the
you can,
order.
like, switch out the numbers, but the fundamental theorem of algebra 1 and
Correct,
the ones like that.
correct. They will be largely the same. Of course, I'm gonna shuffle them around, so don't just
Yeah.
memorize the letters. There's gonna be B, A, C, no, that's doom.
Yeah,
Don't do
yeah.
that. But, yeah, the substance of those problems will remain the same. There should be no surprises.
Okay, so it's not,
There's
you're not
no-
gonna throw
no
like
shocking
Descartes' rule on there and stuff?
No,
Okay,
correct.
Good.
It's nice if you know that, but we're gonna be using Descartes' rule of science in number 9. So that's why I'm not testing on. Questions? Yeah. Did I? I have no idea. Go for it.
Okay, I can't see you.
Oh, I'm sorry, yeah. It's really good.
No, you're fine.
Hey, go ahead. Here's a,
For number 9,
yeah.
is it, when you look at the first one, it's really okay.
It is, but go ahead, I can hear you.
Okay, when you look at the first one,
Uh-huh.
is it on top, is the first, term on top, like, of like the options? You know what I'm talking about?
Oh, for the, rational root theorem?
Yes, yes.
Okay, so giving you all the possible rational roots. Hang on a second.
Oh,
And, yeah,
it's
That
really
was like-
okay.
it's just
A
a,
lot of people walk by.
there we go. I'm only gonna see you for 2 more days. I'm gonna be your servant. So,
Okay.
just, you know.
Go on.
But, number 9, the rational root theorem is factors of the last over factors of the first. Yeah, the one stupid thing is still,
You're fine.
sure,
It
okay.
helped a little bit, it helped a
Okay,
lot.
thanks. Now, number 9, you tell me, Jack Lau, number of, it says the number of complex roots, which means the number of total roots.
6,
How do you get that so fast?
because there's, goes to the degree of 6,
Degree of 6, what theorem is that?
the fundamental theorem of algebra.
That's the fundamental theorem of algebra. The number of roots is equal to the degree of algebra. All right, how many possible positive roots? Can somebody tell me how to do that? Polly, help me out with that. How do you get the number of positive roots?
4, 2, 0.
How do you get that?
So you count the switch, like the sign switches.
Right, count the sign switches from term to term. Now, a quick way to do this, make sure you don't skip any, but you can just do the numbers if you don't want to write all the other stuff, especially if you're crunched on time. I think it's 39, -8 and 20. You see what I did? I just wrote the coefficients. That's good enough to count sign switches. So I see 1 sign switch, 2 sign switches, 3 sign switches, nothing, 4 sign switches. So for the number of positive roots, it's either 4 or what? What was that again? 2 or 0. Explain why the or 2 or 0. What's that all about?
When you have the imaginary numbers,
Yeah, imaginary numbers which wouldn't count as positive. Why is it or 2 or 0?
because they come in pairs.
They always come in pairs. The fake imaginary roots always come in pairs. So there could be 4 positive ones, or 2 of them could be fake, or 4 of them could be fake. Always come in pairs. The fake ones are radicals, and they always come in pairs. Yeah, that's good. Now, how many negative roots? Tell me how to do that. A lot of people just assume, well, it's going to be, if there's 6 total, then you just subtract. That's not always true. You have to do it by hand. Yeah.
So it's f of the negative x?
Correct, f of negative x. What difference does that make? What switches? This is 2x to the 6th, by the way.
Yeah, so that one stays the same,
Okay,
right?
that's 2.
And then, so there's 1 right there because change to 5.
Okay, so the switches?
Yep.
Okay, how about this one? No. This one?
Oh, does it switch?
Yeah.
That one, yeah.
Yes. How about this one?
No.
No. How about this one?
Yes.
Yes, the positive and this?
No.
No, because it's x to the 0, even. How many sign switches? Let's count them. 1, is this sign switch?
I can't see.
Oh, sorry.
No.
No. How about from here to here?
No. No. Yes.
Ah,
The 2.
no. So it's either 2 or,
0.
correct. The the number of negative roots is either 2 or 0. What is that called? That rule that lets you find the number of positive roots and negative roots. It's named after a famous mathematician.
Descartes' rule.
Descartes' rule of signs, S-I-G-N-S. Signs as in positive or negative. Switching signs. Descartes' rule of signs. So in case that shows up on page 1, which probably won't, but you have it. Everybody writes it up? All right. Possible rational roots. Let me see. Keith, possible rational roots.
So is that where you like take the factors of the first and the last?
Yep, and put which one where?
So the one on the ends of 20 would go on top.
Okay. And what about 20? What would I write?
Oh, so you get 1 or 20,
1 and 20.
2 or 10,
Oops.
and then 4 and 5.
Correct. I would do them in pairs like that so you don't miss any. If you just start shooting in the dark, is there 1, 2, 4, 5, and you're trying to do them in order, you might miss some. So what if it's in the bottom?
1 or 2.
1 or 2, that's it. This is acceptable as an answer to that. Just be aware that in real life, that means all the possible fractions. So 1 over 1, 20 over 1, 2 over 1, 10 over 1, 4 over 1, 5 over 1. Negative 1 over 1, negative 2. Then 1 half, 20 over 2, 5 over 2, yada, yada, yada. There are some duplicates in there also. But, make sense? Alrighty. What is the interval on which the real roots lie? Between what and what?
Negative 20 and 20.
Yeah, all the roots have to be between negative 20 and 20.
On your answer key, it says -4.
Yeah, just ignore that. Yeah, they're being sneaky. They're covering a topic we didn't cover yet.
Yeah, that confused me so much.
Oh, sorry.
What the heck?
Yeah, that next chapter we're going to cover that. That's something called the upper bound test and lower bound test. That's not for now. But right now we're just going to do from negative 20. And frankly, some classes don't teach the upper and lower bound test because it takes forever to find them, and then you'll be guessing a long time anyway. So I'm not sure if it's saving any time.
Mr. Coughlin,
Yes.
how did you get that?
You what? Oh, the last term plus or minus the last term. Predict period. So look at the very, very last number on your polynomial.
Right.
It's between the negative version of that and the positive version of that. All the roots are between that.
Oh, you have to write that?
Oh, definitely, yes. Yeah, that's the interval on which the real roots lie. So you should never have to guess negative 40, or negative 30, or negative 21, because anything between 20 and negative 20 is all you have to worry about. Okay.
Okay.
All right. Now let's actually start attacking this thing. Can you find any roots in this thing?
We already have 2.
We already have 2. Name one.
Oh, negative 1 plus,
Negative 1 plus radical 6. What's the other one? Well, what's the other one have to be?
negative 1 is minus.
Minus radical 6. What special word is that? There's negative 1 plus radical 6, and it's what? Starts with a C. Yeah. Conjugate. Correct. The conjugate of any radical is also a root. The conjugate of any radical root is also a root. It's called the conjugate. The full name is the conjugate root theorem. The conjugate root theorem says if a radical root is in your polynomial, then its conjugate is also a root. So what do you want to do? How many roots total again? 6. You found 2 of them. There are 4 left. How do you suggest finding them?
You start with 1.
Yeah, you can start guessing. Start with 1. Use synthetic division. I'm going to write the numbers. 2, 4, negative 3, 14, negative 39, negative 8, and then 20. Is that right? Run it for me. Anybody? Who's feeling up to this? Holly, help me out here.
Two.
2. Then multiply is 2. Add. Multiply. Keep going. Okay. 17. Okay. Negative 22. Okay. Okay. Negative 30 and 20 and negative 30. Negative 10. Did it work? No. So try another one. Negative 1. Okay. Now again, you'll have to start over. 2, 4, negative 3, 14, negative 39, negative 8, 20. Go for it. And by the way, this one is a little bit more unfriendly than the real test.
Oh, yeah. This one looks,
Okay, I'll rip it through for a second. 2, negative 2, 2, negative 2, negative 5, 5, 19, negative 19, negative 58, 58, 50, negative 50, negative 30. Unfortunately, so sad.
Hello, Mr. Kaplan. I'm sorry to interrupt. Could the 8th grade grab their coats very politely and quietly?
Yeah, absolutely.
Thank you.
No problem. So, 1 and negative 1 were in our quiver. Unfortunately, it did not work. That would be logical. By the way, here's my advice to you. If 1 and negative 1 have not worked, because you're going to have to start guessing 2 and negative 2, 4 and negative 4, 5 and negative 5. I would try 1 and negative 1 first. If they don't work, as brutal as it is, I would recommend ripping these out. I would recommend doing synthetic division on this. It's good practice for one thing, and it's guaranteed to work for another thing.
Should we do that now?
Yes. Try it. As long as they gave you a root, might as well use it. Just write it like this: negative 1 plus radical 6. Just be prepared to do a little bit of scratch work on the side. So this is box number. 2, 4, negative 3, 14, negative 39. I would give yourself more space than I'm giving myself. Now again, breathe. Don't forget to breathe. That's a very good advice during a test. Add. Yeah, go. All right. So who wants to do this? Who's feeling brave? I'll do this for you. You're welcome. Yeah, thanks. Multiply. What's 2 times negative 1? Negative 2 plus 2 times radical 6? Right. So what is it? Now add. Just add the like terms. 2 plus 2 radical 6. That's all you have to do. Now you do have to multiply this to this. That'll be a FOIL problem. I would write it out. Don't try doing that in your head. Negative 1 plus radical 6, 2 plus 2 radical 6. FOIL it for me. Multiply. Negative 2 plus good. Then you enter. Yep. What's radical 6 times 2 radical 6? Yes. What is 6 squared? What is radical 36? It's 2 times the number 6. Another way to think of that is radical 6 times radical 6 is 6. So 2 times this thingy is 2 times 6. What is that, really? Well, actually, you're true. You made it a little earlier.
Oh.
This is 12, and then minus 2 is 10. What happens here? Yeah. Well, it's 10. It should work like that. Whenever you have a root that's guaranteed, and you say, oh my goodness, look at that horrible FOIL problem, the two middle terms will cancel, I guarantee it. So, add and get 7, multiply. There's 7, plus 7 radical 6. If you know they're going to cancel, -1 plus radical 6, and then -7 plus 7 radical 6, you could even skip the outer and the inner if you want. If you know they're going to cancel, and the only way I know they're going to cancel is because I know this is a root. The icky stuff has to cancel by the time we're all done. So, FOIL it.
Wait, why don't we add?
Oh, heavens to me. Oh, yeah, actually, I think I did.
Oh, okay.
Oh, there should be positive 7.
Yeah,
Okay.
okay.
7 plus 7 radical 6. Yeah, thanks for catching that. So, multiply. First is -1. -7. Skip the outer and inner. It's going to cancel. Can somebody tell me what this is? 7 times 6, which is 42 minus 7, 35. Add this, you get -4. Multiply, you get +4 plus -4 radical 6. Keep going. Add. Anybody? -4 plus -4 radical 6. FOIL, but remember, in any FOIL problem with a guaranteed root, you can cancel the outer and inner right away. -1 plus radical 6, -4 plus -4 radical 6. You tell me, multiply. 4. Cancel the outer and inner, and then multiply.
-4 parentheses 36.
Radical 36.
Oh, just 6.
Yeah. What is that?
-24.
Yeah, 4 minus 24 is
-20.
-20. Good. By the way, cancels. Ta-da. Now that was a little brutal. The next one is going to be better. What is the other guaranteed root?
-1 minus radical 6.
Do that one. It's going to be, you will not have to FOIL on this one. Bring the 2 down and then multiply.
Should we just start with those when we do it?
That might not be a bad idea. They are guaranteed, so you're guaranteed to get a good progress here. 2 times this thing.
Okay, and -2, -2 radical 6.
What happens?
Cancel.
Cancel. 0. No FOIL. Multiply this and you get what?
7.
0. 7 plus 0 is?
7.
Multiply.
We have 7 minus 7 minus 6.
What happens?
Cancel.
0. 0. -4.
-4 times, I'm sorry, 4.
4.
plus 4 minus 6.
What happens?
Cancel.
Cancel. 0. 0. Ta-da. So you got 2 roots out. How many roots are left?
4.
There are 4 roots left. Good. This was 2x to the 6th. What is it now? And now? This is 0x cubed. This is 7x squared. That's 0x plus -4. Let me translate that. 2x to the 4th plus 7x squared plus -4. How many roots are still in there?
Oh.
4, the degree. There are 4 roots still in there. Does anybody know how to tear that apart? You could keep guessing. I'll tell you right now, that would be kind of an exercise in futility.
Could you do,
As a matter of fact, you could. If you do something called substitution. U equals x squared. Does anybody feel up to factoring that? This is a magic problem. Multiply. -8 x to the 4th. It's going to be something x squared times something x squared. So 1x squared times negative 8x squared. 2x squared times negative 4x squared. 4x squared times negative 2x squared. 8x squared times negative 1x squared. Do either of those work? I want to add up to 7x squared. The last one. This is called the magic pair. What do you do with it? Plug it in. Do it.
2x
Uh-huh.
plus 8x squared
Uh-huh.
plus negative 1x plus
1x, sorry, I mean 1x, I forgot.
Oh.
I ran over it. And then plus, what am I supposed to do with that? Group it. Do it.
2x
Good, what's left behind?
x squared plus
4, good. Plus
negative 1
negative 1, what's left behind?
x squared plus 4.
Is this gonna work?
Yeah.
Yes, pull the x squared plus 4 out. If x squared plus 4 times what?
2x squared plus negative 1.
Yeah. And set it equal to 0 to solve. Do it, math people. Say what? Jack Cloud, take over.
Okay. So you do x squared plus 4 equals 0.
Okay.
And then I guess you can set the other one equal to 0 separately right now as well.
Okay.
And then,
Solve.
you subtract 4 from both sides.
Okay.
Then you take the square root of both
Okay.
sides. It cancels the squared and plus minus negative 4, which is, 2i.
Prove it.
It's, radical 4 times radical negative 1.
Yeah.
Radical negative 1 is I. So then you have 2, which is radical 4.
Plus or minus 2 I. You got 2 more roots. 2 more to go. Solve. Jenna.
So 2x squared equals 1,
Good.
and then divide by 2,
Divide by 2. So x squared equals
1/2,
1/2. Keep
and
going.
then square root that.
Good. So x equals plus or minus the square root of
1/2.
1/2. Does that reduce? What's the square root of 1?
1,
1. What's the square root of 2? Trick question.
square root of 2.
Except there's one teeny thing wrong with that.
Can't have it in the basement.
Can't have a radical in the basement. How do you cure it?
You multiply by no?
This one, you cancel the radical with another radical. Go.
Would you like to multiply the top and the bottom by radical 2?
By radical 2. What do you get?
Radical 2.
What do you get? Radical 2 over.
Radical 4, just 2.
Bingo. You have all 6 roots. You're done with the solving. Let me list the roots. List the roots. X equals negative 1 plus radical 6. X equals negative 1 minus radical 6. X equals 2i. X equals negative 2i. X equals radical 2 over 2. X equals negative radical 2 over 2. There you go. And the last question I wanted you to do is, can you factor that original problem? How many parentheses should it have? 6. What number should be in front? 2. Good. We have a height multiplier. Can somebody tell me what goes in each and every one of these parentheses?
You do x minus 1.
X minus this thingy,
So negative 1 plus
and how about this one?
x plus,
Actually, sorry, I should have put that in parentheses. X minus thingy, and then X minus other thingy. Okay, keep going.
and then you have x minus 2i,
Okay,
and then x plus 2i,
good.
and then x minus square root 2,
And X
and then x
plus.
square root 2.
Done.
Mr. Cochran,
That's the Yeah, that was actually, the computer decided to say, I can simplify that. They distributed the negative.
Okay.
So can you do that? Yeah, if you want. I'm a little nervous when they do that, because it's kind of sloppy. But yes. Questions? Yeah.
When you put the 2 in front,
Uh,
you pull it out. Where did you pull it out of?
Where do you pull it out of? The short answer is it doesn't have to be pulled out of anything. The longer answer is it came out of here. This is actually, if you multiply these together, it's really x squared minus 2. So it'd be 2x squared minus 4. That's where it originally was. So, questions? Okay, and I will make the that problem a little less gruesome on the test. This one was brutal because it had no rational roots. None. The list of possible rational roots, skunked. There are 4 irrational roots. 1, 2, 3, 4, and then 2 non-real ones. This is about as brutal as you're going to get. This is just to build up your mental muscles. Let me grab up the, that didn't make any sense. Let me grab the, let me pick up and grab, that's what I'm going to say. You got stuff in there.
I'm like, yeah, I'm over here. I'm not gonna stay, hey. I'm so pro-life Republican Catholic. He's gonna do that.
Once you're done grouping over there, after you're grouping, and then he has the 2x squared minus 1 plus.
You should know
So
better.
then you put
I
2x
would say
squared
my
minus
dad
1
would just have it for the heck of it again.
And I should know better.
Yeah.
Knowledge, not
Look at that x squared.
Okay, that's interesting.
Yeah.
This is the second version.
And then
The test, I actually titled it practice test B, so that no need to label it. I'm gonna go get the other ones in a moment.
I mean, if you said he was,
These are for your practice. Yeah, problem. And there are some answer keys in here, although I had to put more paper in.
he's fine
Those are my
with, like,
You might want to write the word key on this thing I'm handing you right now.
but not like.
This is the key. The answer key. Yeah, that's a key. No problem. The key and yours is coming. You grab that.
Wait, what day is tomorrow's test or are we doing it on Wednesday?
Okay.
Scrapbook is the test tomorrow.
The test should be tomorrow, and I will open up the, I will stay in during lunch for anybody who wants to go over any last minute questions for tomorrow. Alrighty, I will let you take the last 7 minutes or so, go ahead and start working at these. I can work through any of them, start to work through them with you, if you like. I'll send copies really on. Okay. We are.
It should always be a possibility, but, you know.